Imagine looking through a telescope and spotting something that's not just rare, but truly alien. Not a UFO, but something possibly more fascinating, a comet that doesn't belong to our solar system at all. In July 2025, NASA confirmed the discovery of a mysterious new space traveler, Comet 3-1 Atlas, the third ever interstellar object we've spotted passing through our cosmic neighborhood. This isn't just another chunk of ice and rock. This object is moving faster than anything we've seen before. Besides human-made spacecraft, it's already breaking the mold by emitting strange dust, showing unusual colors, and coming from a region of the sky astronomers rarely get to monitor. It's bigger than its predecessors, it's brighter, and it could carry clues about other star systems or even the ingredients for life. Let's unpack this exciting celestial mystery, starting with how this wild comet was even discovered. The discovery, a blink and you'll miss it object, it all started on July 1st, 2025, when NASA's Atlas Survey telescope in Rio Hurtado, Chile, spotted a fast-moving object in the sky. Initially labeled A1PI3Z, it looked like a simple dot, but astronomers quickly realized something was off. It was moving way too fast to belong to the solar system. This thing wasn't orbiting the sun, it was just passing through on a one-time interstellar visit. Follow-up observations using other telescopes, including the Zwicky Transient Facility, confirmed the object's insane velocity, 61 kilometers per second. That's around 136,000 miles per hour. To give perspective, that's faster than any natural solar system object ever recorded, other than our own spacecraft. Because of its speed and trajectory, 3I Atlas was confirmed to be on a hyperbolic orbit, meaning it isn't gravitationally bound to the sun. It came from interstellar space and will soon head back out, never to return. That velocity also implies it was likely ejected from a distant star system long ago, flung into the galactic void, and only now flying past our cosmic doorstep. A mysterious comet, not an asteroid. At first, scientists weren't even sure what kind of object they were looking at. Was it an asteroid? A rocky, inert body? Or was it a comet, icy and active as it gets closer to the sun? The answer came quickly. A coma, a cloud of gas and dust, began forming around the object, confirming that it was indeed a comet. Even more intriguing, the coma had a reddish tint, much like the previous interstellar comet 2 First/Borisov, discovered in 2019. This red hue suggests it contains a significant amount of dust, possibly unaltered since it left its home star system. But this is where things get even weirder. The coma is so thick that scientists can't even see the nucleus of the comet, its solid core. That means we don't yet know how fast it's spinning, what its surface looks like, or even how big it truly is. Current estimates suggest it could be up to 20 kilometers, 12 miles wide, making it the largest interstellar object we've seen so far. But because it's so shrouded in dust, it could also be significantly smaller. One thing is clear. This comet is different. It's already active despite being far from the sun, and that activity is giving scientists their first glimpse into the chemistry of objects formed outside our solar system. A once-in-a-lifetime orbit and a bad timing. As with many interstellar objects, 3I Atlas is just passing through on a one-way trip through the solar system. It will reach its closest point to the sun on October 29th, 2025. But there's a frustrating twist. On that day, it will be directly behind the sun from Earth's perspective. That means we won't be able to observe it using ground-based telescopes during its most active phase. It's a classic case of bad cosmic timing. However, not all hope is lost. Around that time, 3I Atlas will also be relatively close to Mars, about 2 astronomical units, AU, away. That opens up an exciting possibility. Mars orbiters, like those operated by NASA and ESA, might be able to catch a glimpse, giving us a unique angle on the comet's activity. Back on Earth, the comet will become visible again in December 2025, but only with the help of powerful telescopes. It won't be bright enough for the naked eye, which adds urgency to studying it now while it's still accessible. Interestingly, scientists believe we didn't discover it earlier because of its original path through the galactic center, a region so dense with stars, dust, and galactic noise that spotting a tiny, fast-moving object would have been nearly impossible. But now that it's been detected, a worldwide observational campaign is underway, with hopes to involve even the James Webb Space Telescope. The James Webb Factor, a game-changing opportunity. Now that 3I Atlas has been confirmed and tracked, all eyes are on our most powerful telescope, the James Webb Space Telescope. Why? Because Webb has the sensitivity to break down the chemical fingerprints of distant objects by analyzing the light spectrum coming off them. And that's a game changer. As 3I Atlas heats up, its ices begin to sublimate, turn from solid into gas. This process creates the comet's glowing tail and fuzzy coma. But more importantly, it releases gases and molecules that Webb can detect and analyze. These gases can tell us what the comet is made of, and by extension, what its home system might have looked like billions of years ago. Think about that. We're potentially peeking into the chemical history of another solar system, a place we may never visit, but whose building blocks are now flying right past our eyes. With Webb's infrared capabilities and the early discovery of 3I Atlas, astronomers have a rare head start. That means better planning, better targeting, and a higher chance of learning what makes this interstellar object chemically unique. Are its ices like those in our comets? Does it carry exotic molecules not seen in our neighborhood? This could be our best shot yet to compare how planetary systems evolve across the galaxy. The bigger mystery, where did it come from? Let's rewind for a moment and ask a simple but important question. Where did this thing actually come from? The short answer is, we don't know. But scientists are already trying to figure it out. With the previous two interstellar visitors, Oumuamua in 2017 and 2I/Borisov in 2019, astronomers were able to trace possible paths and suggest a few candidate star systems. But 3I Atlas gives us a better shot, simply because it was discovered much earlier in its journey through the solar system. That early discovery means we can more accurately calculate its trajectory and perhaps trace it back to a source star system. Maybe one that ejected this object billions of years ago due to a massive planetary collision, gravitational tug, or supernova event. And if we do manage to pinpoint its origin, we'll have direct physical evidence from that system in the form of gas, dust, and ice. An alien time capsule, if you will. But that's only half the story. The other big question is, how did it get here? Comets don't just drift between stars for fun. They're flung, ejected violently from their home systems by some massive force. Understanding this ejection process may help us explain how entire planets, moons, or even early life forms could theoretically travel between solar systems. That ties into a much bigger theory, panspermia, which we'll get to in a bit. It's big, bright, and packed with secrets. Among the most exciting things about 3I Atlas is its brightness. This object is extremely reflective, far more than expected, and that gives us a huge advantage. Why is it so bright? Likely because its surface is covered in fresh, pristine dust, material that may have never interacted with a star before. That means we're looking at unchanged cosmic ingredients from a completely different system, possibly from the early days of its star's formation. This comet could be the oldest untouched material we've ever seen. Even better, because it's so bright, it will be easier for multiple telescopes to study, even if they are not space-based. Observatories around the world can collect high-resolution data, increasing the odds of unlocking its secrets. Now, in terms of size, while we don't have a definitive answer yet, scientists estimate it could be up to 20 kilometers wide, the largest of the 3 interstellar objects we've detected so far. For comparison, that's larger than the object that wiped out the dinosaurs. It's ironic. We can't touch it. We can't stop it. But it's leaving us clues about a star system possibly hundreds of light years away. This interstellar wanderer might be fast, but not fast enough to escape the scrutiny of 21st century science. No missions, but the future is catching up. Here's the sad part. As incredible as 3I Atlas is, we can't catch it. It's simply moving too fast. There's no spacecraft currently in existence that can intercept or rendezvous with it before it disappears into interstellar space forever. And that stings, because this could have been the ultimate opportunity to physically sample interstellar material. But the good news? We're learning, and we're preparing for next time. In fact, the European Space Agency's Comet Interceptor mission, scheduled for launch in 2029, is being designed for this exact type of situation. It will sit in space and wait for a suitable comet, likely even an interstellar one, to pass nearby. When that happens, it will launch smaller probes to intercept and study the object up close. Imagine the possibilities. Flying alongside a visitor from another star system, scanning it in real time, maybe even collecting particles. We're not quite there yet, but we're getting close. And 3i Atlas is helping us plan smarter. It's a case study in what we need to prepare for. The speed, the unpredictability, the narrow window of opportunity. Next time a traveler like this comes by, we just might be ready with the tools to greet it, not just from afar, but face to face. Vera Rubin Observatory, the real game changer. While James Webb and space missions get the spotlight, another silent powerhouse is preparing to change everything. The Vera C. Rubin Observatory in Chile. Scheduled to become fully operational soon, this observatory is built for wide-field sky surveys, meaning it can scan huge portions of the sky every night, repeatedly. Why is that important? Because statistically, there are likely tens of thousands of interstellar objects currently passing through or near our solar system. We just don't see them yet. But once Rubin starts scanning the skies with its 8.4-meter mirror and ultra-fast camera system, it's expected to detect dozens of new objects every year, including more interstellar visitors. That means discoveries like 3i Atlas won't be once-in-a-decade events. They could become monthly occurrences. And with that influx of data comes a flood of new scientific opportunities. We'll be able to map out how these objects behave, what they're made of, and even how common certain chemical signatures are across the galaxy. Even better, the Rubin Observatory can spot objects very early, giving us the crucial time window needed to study them thoroughly, or potentially even prepare intercept missions in the near future. In short, Rubin might be the key to turning these rare cosmic sightings into a routine part of exploration. Are we getting closer to discovering alien life? Now let's talk big picture. Life. What if these comets aren't just chunks of ice and rock? What if they carry the building blocks of life itself? The theory isn't science fiction. It's called panspermia. The idea that life, or at least organic molecules like amino acids, can hitch a ride on comets and asteroids, potentially seeding life when they crash into planets. If that's even remotely true, then every interstellar comet becomes a biological message in a bottle, flying between stars. We've already found organic compounds on comets in our own solar system. Now imagine what we might discover from a comet formed in a completely different star system. Could 3i Atlas carry alien amino acids or molecular clues from its home? Maybe. And as we analyze the gases released from its surface, we might uncover chemical patterns we've never seen before. This is where astronomy meets biology. This is the frontier where we ask not just what the universe is made of, but whether it's teeming with the ingredients for life. And every interstellar object that passes through gives us one more shot at finding out. The bigger picture. Our solar system as a galactic catcher's mitt. What if we told you our solar system is like a cosmic catcher's mitt, floating quietly in space, constantly getting pelted by stray objects that have been wandering for eons? That's exactly what's happening. Comets like 3i Atlas are the proof. These interstellar visitors aren't just anomalies. They might be common, just extremely hard to detect. Our solar system, with its gravitational reach, naturally scoops up these passersby from the void between stars. The real challenge has always been seeing them in time. Now, with better telescopes, faster AI-driven sky surveys, and missions in the works, we're finally turning the corner. Instead of getting lucky once every few years, we'll start expecting these visitors. And each one could carry its own secrets, chemical fingerprints, trajectories that hint at distant origins, even potential life-forming compounds. That's what makes the discovery of 3i Atlas so powerful. It's not just an icy space rock, it's a messenger from another world. One that can teach us about how planets form, how solar systems evolve, and how materials might get shared across the galaxy. If this kind of deep space mystery excites you, make sure to like the video, subscribe, and ring that notification bell so you never miss another wild discovery. Drop a comment below. What do you think these visitors might be hiding? And if you'd like to support this kind of content, check out the links in the description for early access, exclusive videos, and more.